Hello, I am Dr. Srinivasa, working as an associate professor and head of the Department of Physics at Government Faculty College, Tumkur belongs to Tumkur University. In this video, I am going to do the class on units and measurements chapter. It is prescribed for the Tumkur University for first B.Sc Physics first sem students for the paper Mechanics and Properties of Matter. So the unit 1, the name of the unit 1 is Basics of Mechanics and the chapter name is Units and Measurements. The learning objectives of this session are accuracy, precision of instruments and errors in measurements, different types of errors, standard deviation. Prerequisites to study this session are units and measurements, dimensions and their analysis, etc. Thus, what are the session outcomes? The students, after studying this session, will able to know what is accuracy, what is precision of instruments, and what are errors in measurements. Also, they are going to know about different types of errors, standard deviation, and also problems. First of all, we are going to know about what is accuracy, precision of measurements, and errors in measurements. Accuracy. The accuracy of a measurement is a measure of how close the measured value is to the true value of the quantity. The accuracy of the measurement is a measure of how close the measured values is to the true value of the quantity. Precision. Precision tells us to what resolution or limit the quantity is measured. Precision tells us to what resolution or limit the quantity is measured. These two, accuracy and precision, can be understood using the example. Suppose the true value of the certain length is near 2.874 centimeter. The true value of certain length of the material is 2.874 centimeter. If a student measured this value in one of the experiments using a measuring instrument of resolution only 0.1 centimeter, the measured value is found to be 2.7 centimeter. True value is 2.874 centimeter. The student in one of the experiments measured using some instrument up to decimal point, 0.1 centimeter resolution as 2.7 centimeter, while in another experiment using a measuring device of greater resolution, say 0.01 centimeter. Here with the first instrument only resolution is 0.1 centimeter. The second experiment with high resolution about 0.01 centimeter, the length is determined to be 2.69 centimeter. Here 2.7 centimeter. Here with the second experiment, with second instrument 2.69 centimeter up to 2 decimal point. The first measurement has more accuracy because it is closer to the true value, because this 2.7 centimeter is very close to 2.874 centimeter. Therefore, in the first experiment, the accuracy is more. It is because it is closer to the true value, that is 2.874 centimeter. 2.7 centimeter is very close to 2.874 centimeter. But less precision, because up to first decimal point only it was measured. Its resolution is only 0.1 centimeter. While the second measurement, that is 2.69 centimeter, is less accurate but more precise, because it is measured up to 2 decimal point, say 0.01 centimeter, like that. So 2.69 centimeter is more precise than 2.7 centimeter, but it is less accurate. So 2.7 centimeter is accurate value, whereas 2.69 centimeter is very precise value. This is how we can understand the accuracy and precision. So let us take another example. So accuracy and precision. The actual length of this person is 3 meter. So the student measured, the different students measured the length of this person as 4 meter, 2 meter and 3 meter. So the correct measurement or precise value is 3 meter because it has high accuracy, and this 3 meter is measured value is very accurate with the actual height or true height. So how close measurements are to the actual value is called accuracy. So in another experiment, so the students measured the actual height of this person as 2.5 meter, 2.4 meter and 2.6 meter. And this 2.6 meter is up to the next decimal point. Therefore, it is more accurate than all these values and also compared to these values. So, precision is how two or more measurements are close to each other. Like that, this 2.6 meter is very precise value compared to these 2.5 and 2.4 meter values. Next, what is an error? The result of every measurement by any measuring instrument contains some uncertainty. The result of every measurement by any measuring instrument contains some uncertainty. This uncertainty in measurement is called an error. The uncertainty in measurement is called as an error. Error is also defined as the difference between the measured value and the true value. The difference between the measured value and the true value is called an error. For example, here the actual length of this pencil is 5 centimeter. A student measured using a meter scale, the length of the pencil is found to be 4 centimeter. So, actual length of this pencil is 5 centimeter. The measured length of this pencil is 4 centimeter. The difference between actual length and measured length is called an error. In general, the errors in measurement can be broadly classified as two types. First one, systematic error, and the second one is random errors. We are going to study each one in detail. So what is systematic errors? The systematic errors are those errors that tend to be in only one direction. These errors may be either positive or negative. The systematic errors are those errors that tend to be in one direction, that is either in positive direction or negative direction. Some of the sources of systematic errors are: what are the sources for the systematic errors? The first one is instrumental errors. The instrumental errors that arise from the errors due to imperfect design or calibration of the measuring instrument. The instrumental errors that arises from the errors due to imperfect design, not a perfect design, or calibration of the measuring instrument. Zero error in the instrument, etc. is the instrumental error for a screw gauge. Next, example for systematic error or instrumental error is that the temperature graduations of the thermometer may be inadequately calibrated. It may read 104 degrees centigrade at the boiling point of water at STP, whereas it should read 100 degrees centigrade. In case of a thermometer, the temperature graduations are not calibrated, are not made correctly. For example, we all know that at STP, the boiling point of water is 100 degrees centigrade. If the thermometer shows 104 degrees centigrade, it is an error. The difference between an true value and the measured value is called an error. The second one, in vernier calipers, the zero mark of vernier scale may not coincide with the zero mark of the main scale. This is also instrumental error. In an ordinary meter scale may be worn off at one end. Then it will not show the correct value of the readings. Second, B1, imperfection in experimental technique or procedure. So, the systematic error is also produced due to imperfection in experimental technique or procedure. To determine the temperature of a human body, a thermometer placed under the armpit will always give a temperature lower than the actual value of the body temperature. So, the second one, third one is personal errors. The personal errors arise due to an individual bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions, etc. So, personal errors arises due to an individual's bias, lack of proper setting of the apparatus, or individual's carelessness in taking observations without observing proper precautions, etc. For example, if you hold your head a bit too far to the right while reading the position of a needle on the scale, you will introduce an error due to parallax. Systematic errors can be minimized. How these systematic errors can be minimized? These systematic errors can be minimized by, first one, improving experimental techniques, and the second one, selecting better instruments, and the third one, etc. Better improving the experimental techniques and selecting better instrument. The second type of errors are random errors. Up to the last slide, we discussed about systematic error. The second one is random errors. The random errors are those errors which occur irregularly and hence are random with respect to sign and size. So, the errors which occur irregularly and hence are random with respect to sign and size are called random errors. These can arise due to random and unpredictable fluctuations in experimental conditions, personal errors by the observer taking readings, etc. Example, when the same person repeats the same observation, it is very likely that he may get different readings every time. When the same person repeats the same observations, if it is likely that he may get different readings every time. If a person taking the readings at different times, if he observe at different readings, then the errors are called random errors. So, least count errors. Example for random error is least count error. So, what is least count? The smallest value that can be measured by the measuring instrument is called its least count. The least count error is the error associated with the resolution of the instrument. What is least count? Least accurately possible measurable distance using that instrument is called least count of that instrument. For example, least count of the meter scale is 1 millimeter. So 1 millimeter is accurately possible measurable distance using a scale. Similarly, 0.1 centimeter is the least count of vernier calipers. Similarly, 0.001 millimeter is the least count of the screw gauge, etc. etc. Example, a vernier caliper has the least count of 0.01 centimeter. A speedometer may have least count of 0.001 centimeter. So, the least count of the vernier calipers is 0.01 centimeter. A speedometer may have a least count of 0.001 centimeter. Similarly, traveling microscope has the same value of 0.001 centimeter of least count. Using instruments of higher precision, improving experimental techniques, etc., we can reduce the least count error. For example, instead of vernier calipers, if we use a screw gauge or vernier calipers or traveling microscope, we can reduce the least count error because they have high resolution. Repeating the observation several times and taking the arithmetic mean of all the observations, the mean value would be very close to the true value of the measured quantity. So, what is the important point is that repeating the observation several times and taking the arithmetic mean of all the observations, the mean value would be very close to the true value of the measured quantity. There are different types of errors. They are absolute error, relative error and percentage error. We will discuss one by one. What is absolute error? The magnitude of the difference between the individual measurement value and the true value of the quantity is called the absolute error of the measurement. The magnitude of the difference between the individual measurement value and the true value of the quantity is called the absolute error of the measurement. This is denoted by modulus of delta A. There is a note. In absence of any other method of knowing true value, we consider arithmetic mean as the true value. So, in the absence of any other method of knowing true value, the arithmetic mean is taken as true value. Let A1, A2, A3, etc. are the measurements made in experiment to measure a physical quantity. Then the errors in the individual measurement values from the true values are, so delta A1 is equal to A1 minus A mean. So delta A2 is equal to A2 minus A mean. A1 minus A mean, A2 minus A mean. Here the magnitude of the difference between the individual measurement, A1, A2, A3 are individual measurement value, and the true value of the quantity is called the absolute error. So similarly, delta A3 etc. delta AN is equal to A1 minus A mean. Delta A1 is equal to A1 minus A mean. Delta A2 is equal to A2 minus A mean, etc. So on, delta AN is equal to AN minus A mean. The delta A calculated above may be positive or negative, but absolute error, that is modulus of delta A, will always be positive. Delta A calculated above may be positive or negative, but modulus of delta A, that is absolute error, will always be positive. The arithmetic mean of all absolute error is taken as the final or mean absolute error of the values of the physical quantity A. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error of the values of a physical quantity A. It is represented by delta A mean. Thus, delta A mean is equal to modulus of delta A1 plus delta A2 plus delta A3 plus etc. plus delta AN divided by N. So, the arithmetic mean of absolute errors is the final or mean value, that is delta A mean is equal to sigma of I is equal to 1 to N modulus of delta A upon N. This is called final or mean absolute error of the value of a physical quantity A. If we do a single measurement, the value we get may be the range A mean plus or minus delta A mean. This implies that any measurement of physical quantity A is likely to lie between A mean plus delta A mean and A mean minus delta A mean. It implies that any measurement of a physical quantity A, the value of A likely to lie between these two range, that is A mean plus delta A mean and A mean minus delta A mean. Next, we will discuss what is relative error and the percentage error. The relative error is the ratio of the mean absolute error, that is delta A mean, to the mean value A mean of the quantity measured. The relative error is defined as ratio of the mean absolute error, that is delta A mean, to the mean value of the quantity, that is A mean. So relative error is equal to mean absolute error over true value or arithmetic mean. That is relative error is equal to delta A mean over A mean. Percentage error. When the relative error is expressed in percent, it is called the percentage error. That means if delta A mean over A mean is multiplied by percentage, that is 100%, you will get percentage error. So percentage error is equal to mean absolute error over true value or arithmetic mean into 100%. Then the relative error becomes percentage error. So percentage error is represented by del A is equal to delta A mean over A mean into 100%. So this is the formula for percentage error. Similarly, we can calculate relative error using this formula. Next, we will discuss what is standard deviation. So, to measure the accurate value in the measurement of values, practical values or experimental values, standard deviation plays an important role. What is standard deviation we will discuss. Let A1, A2, A3, An are the measurements made in experiment to measure a physical quantity. Then the mean value of the measurement is given by, you already know that A mean or Am is equal to, so A1 plus A2 plus A3 plus etc. An over n. The absolute errors in the measurement is given by, you already know that what is absolute error. So delta A1 is equal to A1 minus A mean, delta A2 is equal to A2 minus A mean, etc. Delta An is equal to An minus A mean. You already know all these things in the earlier slides. The delta A calculated above may be positive or negative, but the modulus of delta A will always be positive. The arithmetic mean of all the absolute errors is taken as the final or mean absolute error. The value of the physical quantity A, it is represented by delta A mean. So thus the mean deviation of absolute errors in all measurement is given by the mean deviation of absolute errors in all measurements is given by delta A mean is equal to delta A1 plus delta A2 plus delta A3 plus etc. delta An over n. Up to this you already know in your earlier slides. The variance in the measurements is given by taking the mean of the squares of the absolute errors in each measurement, and it is denoted by sigma square. This sigma square is called standard deviation, or sigma is called standard deviation. First we will know about this sigma square. The variance in the measurements is given by taking the mean of squares of the absolute errors. So here sigma square is equal to delta A1 square plus delta A2 square plus etc. delta An square over n. We will define standard deviation as the square root of the arithmetic mean of the squares of the deviations. So standard deviation is given by the square root of, this is the square root of the arithmetic mean. These are the arithmetic mean of the squares, delta A1 square, delta A2 square, like that, square of the deviations. Or standard deviation of absolute errors in the measurement is also defined as the square root of the variance in the measurements, and it is given by sigma. So sigma is equal to square root of delta A1 square plus delta A2 square plus etc. delta modulus of delta An square upon n, where delta A1 plus delta A2 plus delta A3 plus etc. delta n are the absolute errors in the measurements of a physical quantity A1, A2, A3, etc. An respectively. So standard deviation is the given by square root of the arithmetic mean of the squares of the deviations. Let us discuss the combination of errors. Errors of a sum, errors of a difference, errors of a product, and errors of a quotient. In an experiment involving several measurements, the errors in all the measurements get combined. For example, density is the ratio of the mass to the volume of the substance. If there are errors in the measurement of mass and the sizes or dimensions, then there will be error in the density of the substance. First we will discuss errors of sum. Suppose two physical quantities A and B have measured values A plus or minus delta A, B plus delta plus or minus delta B respectively, where delta A and delta B are their absolute errors. You already know about the absolute errors, that is delta A and delta B are the absolute errors. Let Z is equal to A plus B. Z plus or minus delta Z is equal to A plus or minus delta A plus B plus or minus delta B. So take common A plus B plus or minus delta A plus delta B. Plus, but A plus B is equal to Z, therefore for A plus B substitute Z plus or minus delta A plus delta B. So right here Z and Z plus delta Z in the Z plus delta Z cancel. So plus or minus delta Z will remain there. So delta Z plus or minus delta Z is equal to plus or minus delta A plus delta B. Or delta Z is equal to delta A plus delta B. When two quantities are added, the absolute error in the final result is the sum of the individual errors. This is the final equations. That is, when we add two errors, the final error is delta Z is equal to delta A plus delta B. When two quantities are added, the absolute errors in the final result is the sum of the individual errors. Second one, errors of a difference. Suppose two physical quantities A and B have measured values A plus or minus delta A, comma B plus or minus delta B respectively, or delta A and delta B, where delta A and delta B are their absolute errors. You already know that. Let Z is equal to A minus B, because difference in error we have to find out. So Z plus or minus delta Z is equal to A plus or minus delta A minus B plus or minus delta B. Take common A minus B plus or minus delta A plus delta B. Similarly, A minus B is equal to Z. So Z plus or minus delta A plus delta B. Delta Z and Z will cancel each other. So delta Z is equal to delta plus or minus delta A plus delta B, and these two symbols are also get cancelled. Or delta Z is equal to delta A plus delta B. When two quantities are subtracted, the absolute error in the final result is the sum of the individual errors. So when we add two errors and subtract two errors, final quantities, the absolute error in the final result is the sum of the individual errors only. What is the rule? When two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Next, the third one is errors of a product. Suppose two physical quantities A and B have measured values A plus or minus delta A and B plus or delta B respectively, where delta A and delta B are their absolute errors. Let Z is equal to A into B, because it is error of a product. Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. So is equal to, multiply these two, AB plus or minus A delta B plus or minus B delta A plus or minus delta A delta B. Dividing LHS by Z and RHS by AB we have. So Z by Z cancel, 1 plus or minus delta Z by Z is equal to Z AB over AB will get 1 plus or minus A delta B over AB, AA cancel, will get delta B by B plus or minus B delta A over AB, BB get cancel, will get delta A over A plus or minus delta A into delta B over AB. So 1 and 1 get cancel each other, we get this equation, and also we can neglect delta A delta B over AB. They are very small and hence this term can be neglected. After this final equation is delta delta z by z is equal to delta a by a plus delta b by b. That means when two quantities are multiplied here, a into b, the relative error in the final result is the delta z by z is the relative error. Final result is the sum of the relative errors of the individual quantities. That is delta a by a plus delta b by b. Next, errors of a quotient. Suppose two physical quantities a and b have measured values a plus or minus delta a, b plus or delta b respectively, where delta a and delta b are their absolute errors. Here, let z is equal to a upon b. Then z plus or minus delta z is equal to a plus or minus delta a upon b plus or minus delta b. So z plus or minus delta z is equal to a plus or minus delta a. Take b as common, we will get 1 plus or minus delta b by b. So we can simplify like this: z plus or minus delta z is equal to a plus or minus delta a over b, and take this to the numerator, we will get 1 plus or minus delta b by b or to the power of minus 1. We will get the final equation. So divide this a by b plus or minus delta a by b into 1 minus or plus delta b by b. We can write this as like this by binomial approximation. So or z plus or minus delta z is equal to a by b plus or minus a by b into delta b by b plus or minus delta a by b plus or minus delta a by b into delta b by b. Dividing LHS by z and RHS by a by b, and simplify, we get this final equation: plus or minus delta z by z is equal to plus or minus delta b by b plus or minus delta a by a. Finally, we get delta z by z is equal to delta a by a plus delta b by b. That means when two quantities are divided, a and b, the relative error, that is delta z by z, in the final result is the sum of the relative errors of the individual quantities. That is delta a by a plus delta b by b. Here delta a into delta b square is negligible in this equation, then only we get this expression. So I have taken these books as references for doing this video. Thank you for your patience. Thank you once again.